So your documentation management is integrated into the other management that we're doing with our ITIL. So what I mean by that is your incident management, your problem management, your knowledge management, right? Sorry, your knowledge base management, which is related between incident management and problem management. Then your configuration management, on which you are doing a video at the moment. These things are all sort of related to each other. So your incident management, you're capturing all kinds of data and information from our customers. Your problem management as well. And configuration management perhaps is most closely related to exactly what we're talking about today. So some of the points that we're going to make today are exactly sort of related to that. So we have a bunch of boxes here. Some of these, so three-letter acronyms. Let me just get my note on this because there's a couple of those three-letter acronyms that I would say are somewhat obscure, and I don't want to mess them up. So the WCM, I made a note on that. I mean, who ever heard of that before? So our three-letter acronyms that we've got there that are important. We got ERM, our enterprise. What do we call that? Hold on here. It's not on the top of my head. Enterprise report management, and our WCAM is web content management. I mean, who ever heard of those things before? Hopefully the other ones there are kind of more obvious to us. But the points that I would just make about this is what we're doing is we're gathering our data from all kinds of sources, and some of those sources are going to be hard copies. And so that's why we're doing things like OCR, which is optical character recognition. Nowadays, this is when this term was first coined, OCR, it was so basic and so horrible. People used to shudder when they used to think about it because we would run our software over OCR. I'm not sure if you're familiar with how it actually works, but basically you can scan anything that's got a bunch of text on it, and the software then will take the pixels that you've scanned and will pick out of them characters and then words and then sentences and then documents, basically. So you can scan documents of hard copies and get from those documents your something that you can edit in a word processor, etc. And so once you've got it in that format, then you can do all kinds of indexing and relating things together and sort of accessing through databases, etc. So I guess what I'd say about this here is that what we've really got is we got sort of an explosion of the technology that goes around this. So the actual amount of data and the relationships between the data are just exploding in terms of the value that we can get out of them. So there's a lot more data. Here is almost, I guess what we're looking at here is how it's kind of almost legacy, because how careful we had to be in the way that we cataloged, that we indexed, and we recorded all of our data in the past. And you'll notice all the separate different database structures that we got here. Each of these, we call them a repository, but basically it's a database stored on a disk drive somewhere. How carefully those have been indexed and sorted. This when your data when you have limited data storage and you have limited indexing and limited speed in those things, then you have to be so careful in the way that you organize your data in your databases. And it was really quite an effort. But I would say that what's happening in the last few years, and we'll see this going forward, is our technologies are kind of morphing over to something that's a little bit more automated, automatic, autonomous, whatever you want to call it. Terms like artificial intelligence you would have heard of, and neural networking, these types of things. So what the more modern sort of way of getting information is we're just picking it up out of the environment, if you like. So we have this thing like the Internet of Things. Basically, any document, any even physical object can be tagged with some kind of like a tiny RFID or something like that, and then it can be scanned, and we can have information about where this thing is and what it's doing at this particular time, and that information can go into huge databases over which very modern and I won't say complicated, but um, our artificial intelligence, how that works is it just builds up its own rules based on the data that it sort of processes. And this is the idea of networks as well. They sort of build their own paths. And so basically, the knowledge that comes out of those systems could not be predicted by a human, because it's basically just made up from patterns. And so if the patterns in the data will produce some knowledge that we will then know from our systems. And this is our artificial intelligence. Um, that's where we're going. I think these images here are where we were, and perhaps we'll still be here for a little bit longer, where we have to very, very carefully organize, design our databases, and look at the structures between them. So this diagram is to represent some of the kinds of data that you information, documents. So this is about documentation that we would need um, to store for our system to be ITIL compliant, and et cetera. So there's some different focuses that we've got here. We've got a focus on security. So though we have a lot of documentation, we want to keep that for ourselves. We want to make sure that that documentation is not going out of our system. So physically not going out of our system, we have all kinds of sort of physical barriers to people taking data out of our system, and then also sort of logically as well. So, for example, if we have a very, very secure, very, very sensitive information, we might do things like separate our network from the internet, so that people can't sort of send things out. We might sort of scan people's um, persons as they leave the building to make sure they're not taking out any digital media. What comes to mind when I'm talking about that is like the Edward Snowden sort of story, and I'm sure you're familiar with him. And he pops up in the news quite often. Very smart guy. But Edward Snowden was working for the United States government in Hawaii, for the what they call the NSA, and he was not happy with the way that the government was um, gathering data on American citizens. And he this was a philosophical problem that he had, because the American Constitution has a bunch of what they call amendments, and one of the amendments, the Fourth Amendment, is that the government cannot sort of do searches on people without any cause. There must be a reason. They can't just for no reason be gathering data about you. And of course, the NSA was, and part of that came out of the events that surrounded 9/11. But anyways, so he, on based on a personal ethical sort of crisis that he had working with the NSA, he couldn't sort of sleep with himself. I don't know. I haven't been inside his head. He's a very smart guy, but he decided that this was not. He couldn't go on with that, and so he took some copies on a bunch of thumb drives of a lot of the data that they had, and he smuggled it out, and then he caught an airplane to Hawaii, and then distributed those. And now he can't go back to the United States because they'll throw him in jail like for the rest of his life. So he's hiding in Russia. I don't know if you're familiar with him, but he's anyways, the point there is they had a pretty good systems to stop people getting their documents out. But if somebody wants to get them out bad enough, like Edward Snowden, and they're smart enough, they're probably going to get them out. There's a point to sort of consider. And there was a lot of sort of flack came out of that, because basically he had information that he had recorded, which which made the United States government look bad. Okay, so the United States government made itself look bad because it did some things that weren't right. But you know, those things are usually kept private from the public, and then they were publicized. And yeah, I mean, you know, people in the United States call him a traitor, right? I mean, you know, that's a very bad thing to be called in the United States. They do have the death penalty. I'm sorry, I'm sort of going on and on about Edward Snowden. It's very, very interesting. If you want to look into that, do look into it. There's a lot of information about it, and he's made movies and stuff, documentaries, etc. I'm sorry, I am raving on a bit. I will stop now. Um, so that's something that, depending on what your organization is, that's something that you would consider very, very carefully. With the IT department, uh, the information that we have about ourselves may be sort of basic, but the information about the business itself is quite a big deal. When I worked for the telephone company, um, one of the big concerns that the telephone company had was its customer account billing system. In the customer account billing system was the names and phone numbers of all of our customers, not just their names and phone numbers, but also their private information that they needed to open an account with us. Now you might say, oh, well, that's not a big deal. You know, you got phone books. Everybody knows everybody's phone number. That's not true. There were a lot of people who had what we called silent numbers, or in other words, numbers that didn't show up in the telephone book because they didn't want to be public. And so, but that information was, of course, all on our systems. And there was a big, big concern in the telephone company about that data going out, especially once we got competitors. So I've got competitors, that kind of information could be used as part of a marketing campaign. And you know, if your competitor knew who your customers were and knew what the contracts that you had between you and your customers were, then they could undercut by $1 or whatever it would take to get a customer to move over and abandon. You know, it'd probably be more than $1 because you know there's a bit of an inconvenience factor. Um, so to be secure, there's here a lot about security. We have our documents. We should have some way of making sure that they're secure. They're not going out of our system. We should have some way of knowing where they are physically when we're talking about physical hard copy documents, and we should have some way of sort of getting that information for reports. And yeah, so what are we talking about? Uh, the next couple of slides are just a bunch of different types of documents that might be recorded and might have to be sort of kept in a organization. So electrical, this is kind of banal, bland sort of thing, crossover diagrams. Yeah, okay. So this one here, electronic diagrams, they might be proprietary. Of course, they'd be a lot bigger than this, but this kind of thing is intellectual property in an organization that is, if your organization is actually building any kind of integrated circuitry, the diagrams related to that are quite valuable and so need to be recorded somewhere. These kind of diagrams would be more familiar to you. Physical network diagrams, all of these diagrams would have to be sort of managed. Now, as I was saying, as opposed to just hard copy document management, a lot of this stuff is going online nowadays, and we know that, right? And so, for example, who looks at paper manuals nowadays? I mean, you know, even when you're buying consumer goods, the manuals for them, you know, people don't even ship them anymore because you can just go onto the cloud and find that manual. So within an organization, you would do that too, using a virtual private network, having a repository to your documents, and so that people could view them and update them and have them in a sort of a, not in the cloud, in a intranet, I guess you would say, that could access those documents. Now, so this is just a type of diagram, and just go back to the previous one, just a type of diagram that you should be familiar with. but that type of information nowadays, you could have software on your network which could sort of in real time update these kind of diagrams by sending information back from the various nodes on your network. So we have sort of gone behind. This is kind of a fast moving area, but these would be kind of interesting for you. Your IP addresses, different um, different nodes in your network, your hosts, your switches, your routers. I'm sure you're all familiar with those. And those can be displayed in a different kind of diagram. Again, these would all still be useful to your organization with your logical diagram um, icons here, like your router, your switches, and your different servers. Don't see any hosts there. The idea here is something that we've spoken about before, the idea of a baseline, which is sort of a picture in time of what our network is doing. You can have software that will record over time the actual availability and the actual usage on the network, and that's what this one here is supposed to be doing. And it has all kinds of colored diagrams and graphs, etc., to show, for example, that at a certain time we have a very high usage, which may indicate that we need to either even out that usage on the network or build in some more capacity. So that's the idea of the baseline. The baseline, as it says, is take inventory to have a look at what our network is doing at a particular point in time, and then to sort of analyze it. Now, I think in the previous lesson, we might have talked about sniffing tools. I mentioned to you Wireshark, which I'm sure that you've all used. We've got some other sort of protocols here. NetFlow is a protocol from Cisco, and SFlow is sort of related to it. And what they do is they can be used to gather information from your network so that you can analyze it, kind of like your sniffing tools. This is just an example for you of a document that might be kept in an organization with IT that has a bunch of rules related to how the documents in your organization are managed. And hopefully that give you some ideas. For my final slide here, this is just I just sort of popped this in here. I was just reading this yesterday, and I thought, hey, that kind of relates to the class that I'm teaching. So you know what, I'm just going to put it in there. So I put a hyperlink there. You can get that and download it if you want to. But it just this article that I found yesterday from the Computer World magazine. And all these magazines are online now, aren't they? So I mean, like I said, we don't have to have hard copies. We don't wait. In the 1980s, I used to read computer magazines, and they would come to me in a big package, and you'd eagerly await every month. This thing would come to you. You'd flip through the pages, look at all the ads, etc. It's not really happening so much nowadays, is it? Right? You get something in your email box, in your inbox, in your email, and that's kind of like this is, or else when you go to Google, there's something there that's risen to the top based on your searches, so because I've been searching a lot, maybe on computer security or something like that, I get a bunch of articles when I look at Google, which are about computer security without the latest thing. And this sort of showed up there. This is not computer security, but about document management. So we have these new sort of software ideas, software applications, Workflowy, Coda, and Notion. And what they basically are is just another way, sort of different than using a spreadsheet or a Word document to keep a bunch of information for us. Workflowy, how it works is it has a bunch of, you have layers and layers of dot points. You click on a dot point and it will open up, and there'll be some more information underneath it. So you can summarize a document in five or six dot points that would take up a page, and then you can drill down basically by just clicking on it and opening up to more detail. And that is has there's no limit to how many levels you can go down in that. So basically, as much you can have as many layers as you've got storage space for it. And so that's sort of a new way of looking at it. It's kind of nice because these are not sort of independent bits of data that are just sort of sitting on a hard drive somewhere. All of those bits of data are linked together through the through the dot points in your document. So that's a very nice way of sort of storing data. And Coda and Notion are similar. Just how they're a little bit different is in the actual sort of way that that's implemented. So with Coda and Notion, uh, uh, blocks instead of dot points. And so a block can hold like a map or a Word document or an image. And so they're kind of uh, just slightly different takes on the same idea, but the idea being that this one document you can use, which sort of pulls in so much information um, uh, and can link other documents. You might say, "Oh, yeah, that sounds like a web page." It's a little bit more flexible than just using a web page. And so I just leaving that with you as a thing to think about. I know that there was I haven't checked on this recently, but I know that there were some places that used to offer a diploma or a degree in what they used to call information management. And so information management would be related to what we've been talking about today. So that would be how we what information we store, how we store it, how we index it, etc. And I hope if you didn't get anything else from this lecture, the idea that you would get is that the the nowadays application of that, I think we're at a tipping point where we can go on um, to get a lot more sort of use out of that. That we can take this information that we have in various silos everywhere, on various hard drives and stuff like that, and we can actually get a lot more value out of it because of the processing methods that we're using. And so I hope that that sort of helps. Um, I'm going to pause now.